Paper of the day is an experimental comparison of 13 relational equi-joins in main memory. Relational equi-joins are at the heart of almost every query plan. They have been studied, improved, and re-examined on a regular basis since the existence of database community. In the recent years, several new join algorithms have been proposed and experimentally evaluated. Some of those papers contradict with each other in their experimental findings. This makes it surprisingly hard to answer a very simple question: what is the fastest join algorithm in 2015? In this paper, they try to develop an answer. They start with an end-to-end black box comparison of the most important methods. Afterwards, they inspect the internals of these algorithms in a white box comparison. They derive improved variants of state-of-the-art join algorithms by applying optimizations like software write combined buffers, various hash table implementations, as well as NUMA awareness in terms of data placement and scheduling. They also inspect various radix partitioning strategies. Paper uses TPCH queries for benchmarking and uses varying page sizes and data size for evaluations. Now let's look at the paper contributions. First, black box comparison of 4 principal join algorithms. White box comparison. They enable all optimizations mentioned in prior work and explore the effects on the runtime performance of the joins. Optimizing join algorithms. In order to improve the join performance on NUMA architectures, they optimize the different variations of the PRB join algorithm. Comprehensive comparisons of joins. They perform a comprehensive comparison of all join algorithms. Effect on real queries. They evaluate the effect of the choice of the join algorithm in the context of a real TPCH query. And lastly, authors share key lessons learned from the experimental study. Now let's look at the lessons learned. First, don't use CPR algorithms on small inputs. Second, clearly specify all options used in experiments. Third, if in doubt, use a partition-based algorithm for large-scale joins. Fourth, use huge pages. Then use software write combined buffers. Then use right number of partition bits. For the partition-based algorithms, use a simple algorithm when possible. Be sure to make your algorithm NUMA aware and be aware that join runtime is not equal to query time. Let's talk PS score. Overall, this paper is an okay read, so it gets 6 out of 10 on readability. With 16 pages long, it scores 7 out of 10 on length. The description of the approach is incoherent at times, so that makes it 6 out of 10. Industry value and learning meter is not very high as it's sort of measurement paper, so it gets 6 out of 10 on each. Overall PS score is 6 out of 10.